Hi, and welcome to the Structural Engineering Podcast. My name is Max.
I'm Zach, and we're here with David.
Every week or so, we like to get together and talk about what's going on in structural engineering. This is episode number 3.
Oh yeah, we've made it to 3.
We made it to
I feel
3.
pretty good
It's
about
moving right along.
One honor. Yeah.
This
We're
one's
going
a
into
little
guests
special.
now too.
We're going into guests. We've made it to guests at 3.
We ran out of ideas, so we started needing to bring it perfect.
And this one is going to be a little different.
Yep.
Because Dave is not a structural engineer.
Oop.
But he does some cool stuff, so we'll learn about it. Dave's a mechanical engineer, right?
Mechanical engineer as a degree, but in terms of job, held a couple different positions. Did a lot of project management, manufacturing engineer, production support, and all that good stuff.
Oh man.
Yes.
Okay.
I feel like out of school,
good
when I
mix.
picture mechanical engineer, it's
Yeah.
like, you build a car.
Yeah, that's what
Oh,
a lot of
yeah.
people thought. You know,
That's-
a lot of people thought it's like mechanics. You know, engines to
Yeah.
just
Like you're just
machinery.
like
You know, it's
Yeah.
it's not that. It's very broad.
Yeah.
It's interesting. Yeah.
I see you in like a machine shop, like machining
Yeah.
things,
Yeah.
and like oh, this car needs to go a little faster. I'm gonna make a new gear for it. You know,
Yeah. But there's
Or-
definitely
Well,
that
a
too.
cog on the
Yeah,
gear.
there's a little
Yeah.
cog.
Yeah, absolutely.
tuning
There's
stuff
definitely
and like yeah.
Nice.
Pretty sweet.
Alright, well let's start with like how you got into what you're doing right now. I
Yeah,
guess. Like, is
engineering.
this your first job out of college?
So right now I
Yeah.
am working at a medical company. That's for those who don't know yet. And I did not start out there. I started out working at a luxury yacht company.
All
So-
right.
Yeah, that
Big
was nice.
roller.
Did you bring any yachts with you?
Yeah. Can we have it? Yes.
These yachts are pretty expensive.
So that's part of this
Too cool.
podcast thing. Like you have to give us something from your first job. So we'll just take a yacht.
Okay, yeah,
Yeah,
I'll just
Yeah.
don't worry, I'll steal a couple. Don't worry. Put in your garage.
3D print you on. We'll call it.
Oh, perfect. There you go.
Full size.
Oh, for sure, flip.
Full size. Yeah.
No, so I graduated in 2015, and that was my first job at a luxury yacht company. So I did a lot of manufacturing support. I would come up with different designs from tables to structural part of the boats, and then
Whoa,
I
okay.
would go down the floor.
He's trying to take what. Yeah, I heard structure. Yeah.
There's a little bit of
Oh,
structure.
you're trying to do our jobs now, huh?
No, good job.
Okay.
And then I would prototype it on the floor, and then give it to the production floor and have them use that as actual pattern or jig, and then they just reproduce that same pattern over and over again.
So when you're designing those elements, full honesty here,
Yeah.
are you using like finite element analysis stuff?
Absolutely no.
Okay.
No.
It's more so the way the camera works is
So like SolidWorks is right for your industry.
even.
Like it's like a mechanical.
it's more of a common yes.
It's-
It's definitely
yeah.
a common CAD software, but in terms of being at the boat company,
Yeah.
we were mainly just more old school style. So we would prototype it by hand,
Shooting from the hip.
shooting from the hip, and then you go and you just test it out. And you test,
Did you have any metrics on like the resistance compared to the last model, like
No.
top speed with the
So
same
yeah,
motor?
we
so
have
at least that-
we have at least
rudimentary.
very basic,
Yeah.
speed to.
Now, I'm sure everyone
how
wants to
well it
know
turns.
this.
Yeah.
Do you guys ever sink a boat?
So
On
far,
accident?
while I was there, we did not sink a boat,
Right.
but there has been.
Like during testing or on purpose?
This was, I was told it didn't fully sink.
Okay.
But it was starting to submerge. So.
Oh, Jesus.
So the boat that they built was too heavy. They didn't do any calculations. They just had too big of
Yeah.
parts and fiberglass, and it's just too heavy. And there's bilge pumps that are within the bottom of the boat, and so it pumps out water.
Yeah.
So it helps, but it wasn't enough. And you got a couple holes in there, anyways.
There's holes.
There was holes. So
Is there always holes, or is this just
No,
the prototype?
it's just
they
prototype,
miss
they-
patches?
I guess use longer screws than they were supposed to. And,
Oh wow.
this was a couple years before I started.
Yeah.
and
Well, of course, once you started, they
Yeah,
don't
once I
have
started, it was perfect.
Yeah.
Perfect boats coming out. Yeah. So yeah, that was pretty
Oh my
scary for
gosh.
part of it. But they were get it in and fix it, patch it up, and sold it.
They sold that boat.
Oh, absolutely. Once you patch up the holes, you can sell that thing all day.
Oh
And
man.
it's on a discount.
It,
On a discount.
it only was failing because of the holes, though. Like otherwise, it was a perfect.
It was just
boat.
a heavy boat.
Yeah, it was just a heavy boat, right? So then the performance of the motors were a little different.
So they've added new props or
So
two.
they added, they added new props.
Okay.
A little bit bigger motor.
Okay.
And this is prototype sell, so it's
Wow.
cheaper than people who want nicer looking boats.
So would that be like a marine engineer? Is that
I guess you could say that, yeah, marine
Okay.
engineer. So in the boat world, they break it out to engines specific.
Yeah.
So you got outboard, inboards, mid engines.
And you're more to the whole.
I'm more to so the company was small enough where I was able to do all of them.
Wow.
Yeah, so I went from the concept to working on the molds being produced, and then producing the parts off the molds, and then working on the interior parts from cushions to
Yep.
tables, and then systems from air conditioning to Webasto units for heaters.
You have air conditioning?
Yeah, they had. So this is when
This
you
is
know luxury.
luxury.
Fancy. This is luxury, right? Yeah, they
Whoa.
got AC, they got heaters, they
My
got
house
fresh.
isn't even that luxury.
Yeah, see, my house don't have air conditioning either.
Yeah, we got AC. We got AC.
It is like a
Yeah,
house.
we got luxury house.
Yeah, we got AC here.
We got AC. It's on right now too.
Yeah, it's
Yeah. 22 degrees outside with snow, and we have the AC on.
perfect
For David, he's warm. He's really warm.
freezing.
Is this so? When you got this job, was this like exactly what a mechanical engineer is kind of like looking like? Was the position for a mechanical engineer, or is this like product design?
Title wise, it
Yeah.
was manufacturing engineer.
Okay.
But I wore so many different hats at that job, which
Yeah.
I guess I wasn't really prepared for. Right? When you get out of college, you don't really have a fair expectation of what
Oh yeah.
Yeah, absolutely.
you're going into, and
So
that's pretty overwhelming. It's kind of
Yeah.
scary.
So that's perfect. So our first podcast
Yeah.
was like our first week as an engineer. So you
Yeah.
wanted like
Oh,
what you
interesting.
expect?
yeah, what
I guess-
and what
yeah,
did
yeah.
you expect and what was reality?
Yeah. So I guess from mechanical, perspective.
Yeah. You thought you're going
I had no
into-
idea. Yeah, I had no idea what I was going to. I was
Yeah.
didn't feel like I was prepared. I was looking over my heat transfer, so like fluid dynamics to make sure I knew basic stuff.
Like some
'cause-
studying before you started.
Yeah, because I figured boats.
Yeah.
You need to at least know basic buoyancy calculations to
Very basic,
thermodynamics and fluid dynamics. So I'm just like, oh shit, I need to really prepare.
Yeah.
For this.
You thought you were screwed.
Screwed, right?
Yeah.
Okay. And
That's similar to our first jobs.
Yeah.
Yeah.
So first interview, they went into. It was more very not technical at all. They're very
Really?
personality based.
Okay.
They're just asking questions like what you do for a living. I'm like nothing yet. What are your
Student.
habits?
Yeah.
Your habits, hobbies, general things that you like doing. And it was just very weird. And I'm like, okay, this is a weird interview because the way they prepped it in school was all these technical questions.
Oh yeah.
Oh man.
Very organized. And once you get into this company, once I got in, they're just hands on. They're like, hey, make this prototype on the floor. So I had some some tool and shop experience.
Yeah.
So I just okay, you got this constraint. This is the area you have to make a table fit within. So just
Did you have a mentor? Was there other engineers at the company that you
no.
worked
So
with?
I had one mentor. Yeah, and he was great. He gave me a couple of directions, but he really wasn't micromanaging, which was another big thing in itself. But he was just like, here's your constraints. Let me know if you have questions. So I'm gonna let you think you're gonna figure out until you need help. So he gave me that, and I was like, yeah, I'm gonna do this. I need tape measures. And so I was doing it the hard way, right? And he's like, one thing I may suggest is cardboard. And so that's all I'm gonna say. And I'm like, well, cardboard. Oh yeah, that's way easier.
Yeah.
No calculations, and you can tape it up, and you get the right shape that you want. And just trace it out on the wood, and you make it look pretty. And if it fits nice, then you can present that to production floor.
Yeah. So
and
in school you use all this fancy software, and they're
Yeah.
talking about like CAD softwares
Right.
and your finite element analysis
Right.
stuff, and then you go to your first job and they tell you to use cardboard.
Yeah.
So expectations
world.
are like
Yeah, I'm like,
all over the place.
you guys have lasers. Like,
Yeah.
like what do you? Yeah, it's crazy. So I did that, and I got really at prototyping things really quickly
Okay.
with cardboard. And then
yeah.
I was like, well, this is not very efficient, right?
Yeah.
From an engineering perspective. So started getting a little bit into lean manufacturing a little bit.
Mm-hmm.
So then I was like, there's these tools you can buy where you can just roll it and then produce like a 2D sketch in the software for you. So you don't actually have to
Whoa.
make the prototype yourself. So yeah, it's basically almost like a little roller.
Yeah.
You roll it.
It like kind of GPS, or is it just knows its position to some reference?
Yeah, so it has like a camera pointing on it.
Okay.
And then you can use this, and I think it knows its location, so it
Yeah.
kind of draws a 2D out. So the idea of it would be to produce a 2D sketch, and then use that, produce the first prototype, and then since it's digital already, you can send it to a CNC manufacturer, and they'll just rapidly make them really quick and accurately.
Now with that scan, would you print that out and then hold it physically there?
Exactly.
Or- okay,
Yeah, exactly.
okay.
So we would, plot them out basically
Yeah.
to scale, and then you would machine or cut out the wood, bring it to the boat, make sure it fits everything right, and then
Yeah.
get it to production. They use routers and whatnot to
Jeez.
repeat the process over and over again. So it's.
Man.
But anyways,
Boat
on a tangent.
Yeah.
But, starting wise, man, I was didn't feel prepared at all.
Yeah.
Definitely overwhelmed, scared. But once I started, haven't done any that in that, at least in that position, I didn't do any math calculations. Very basic, like
Yeah.
voltage when we're doing electrical systems, but
Wow.
nothing.
Like most mechanical.
Like most of them.
Yeah.
But yeah, very basic stuff. But yeah.
No software use. I mean, other than like this positioning you were talking about, but as far as like, modeling, they didn't even have anything, or did they have stuff?
No, they did. Yeah, they did.
And
They
they
absolutely
just
did.
didn't.
Yeah, so they'd use Unigraphics, NX8, NX7, and it's basically like SolidWorks. Yeah, this is
SolidWorks.
the difference.
Yeah.
This is the difference between mechanical engineers and structural, right? So there's different softwares.
Oh
out
no
there
no
for-
no no! We're just awesome.
Oh, you guys just know everything, right?
Yeah.
Yeah.
Everything.
Perfect.
Yeah.
Not that one thing.
But not that one.
Just this
thing.
one example.
Or boats at all. But they. Yeah. Okay. Anyway.
So, anyways, we use that software to produce these molds. So we send it to, these third-party companies that make that have huge CNC equipment.
Yeah.
And they basically machine these molds out for us. So they have software.
What are
there.
they CNC out of? Is like a metal?
Yeah. So they started out with like almost like a fiberglass mold,
Yeah.
and then they machine it out, and then they do different layers of coating to create this mold. And then they would wax this mold so that you can pop your part off of it. But the backing of it is all structural stuff, which actually structural engineers go in and do those and perform those calculations.
There you go. And that's
Yeah.
just so
Because you need to bring a
have
structural engineer when you got to do calculations.
Exactly.
When you really need to run numbers.
We don't do math. That's
Yeah, we
not-
don't do math. We'll
yeah.
hire these guys.
Exactly.
Okay.
Yeah, it was interesting though. So they did that because there's like a 30-foot boat, so there's a lot of mass
Yeah.
and load in certain areas. So you just need support in certain areas. And there's your expertise. So what I did sometimes is when we didn't have the opportunity to bring in a structural engineer, they would have us come down and like, hey, well, what do you think? I'm like, well, where's the weight at? Where's the center of gravity at? And we start from there, and then we just started adding basic structure supports that we think would benefit. And so, for example, on top boat, you can imagine there's the deck portion, which is the top part portion of the boat, and the front half is usually a little heavier, just because there's more material there. The back's a little lighter. But when you're laying up a mold, you're having this whole thing upside down, right?
That's heavier.
The front's a little heavier. So imagine like it's like a house.
Like the mold, not the boat, right?
Yeah, this is the mold part.
Oh,
This is
the mold, yeah.
So the front of it's just
Yeah.
a little heavier.
Oh yeah, yeah.
Yeah, they're not putting the engines in.
Yeah. No. In general, the back is usually heavy. Otherwise, yeah.
Yeah. All right.
Yeah, that'd be weird. New style of writing. Though. Gangster style.
Gangster style.
Yeah, so
Oh.
the boat's heavier top end,
Yeah.
the mold side, and so when you flip it over to lay up the fiberglass, you got to keep that in mind because this side will be leaning and this side is really loose, right? So sometimes we just go in and add a couple,
Just
pipes
keep it
here and
really
there,
rigid.
just keep it very rigid. Yeah,
Huh.
exactly.
How thick
So-
is the fiberglass? Like, how thick is the boat hull?
So fiberglass, in terms of the hull, which is the bottom portion of the boat, I think it goes from ½ inch all the way up to a couple inches. It depends on the size of
A
your
couple
boat.
inches.
Yeah, so the couple inches is like I'm thinking like mega yachts,
Yeah, yes.
really big boats.
Ice breaking.
It's pretty
Tankers.
big. Yeah.
Exactly, huge, and I may be way out the numbers. I've never been on mega
Yeah.
yacht myself yet. One
Yeah,
day.
yeah. I mean, you own one, but you've never been on
Yeah,
it
yeah,
yet.
exactly.
Yeah.
But so the biggest boat we built was, let's see, a 38 footer. I think it was in the progress as I was transitioning to a new job.
Seagoing boat too.
This is a seagoing boat.
These are all
yeah.
seagoing
Yeah,
boats.
they're
Okay.
yeah. So the one
That's
that
big.
yeah, this is
38
the
feet is huge.
yeah. So
We'll get there one day, Max.
Yeah.
Yeah,
Our
It's a big
15-foot
fishing
boat, we'll get up there.
yeah, just
We'll get
multiply
up
a couple times. No,
Yeah.
yeah. Just cut it in half and attach
Yeah.
it and yeah, you're solid.
there. Yeah,
Perfect.
we could do that.
Yeah, easy. I hope you.
On another podcast, follow us as we build the boat.
Structural.
Straight, yeah.
Full structure boat.
Oh yeah. We'll just cut boats. We'll just keep cutting boats and adding them. And
That's
that's how it
picture
works,
like
right?
a train of little junky aluminum boats.
Yeah.
Yeah, just
Bunch
Oh, we
of
don't do
canoes,
that. We
38
tie them
feet of
together.
canoes.
Yeah.
perfect.
Okay.
Um,
Okay.
Yeah, so
Yeah. Approved by David.
there you go. I'll just give a stamp. You're gonna sink.
We're gonna sing for sure. We swim with the
So
fishes.
yeah, man. In terms of thickness, though,
Yeah,
I think
right.
½ inch is pretty
Okay.
fair.
That's a lot of
half inch
fiberglass.
too.
Now, in the boat world, is things metric or U.S.?
Like
You're talking
a little bit of
inches
both.
now.
Yeah, so a little
Okay.
bit inches. The material we use, the core material from Smurf material, which is something we I think it's a nickname, but it's basically this blue material that's just gives a thickness to the fiberglass. You also have foam. You have Penske board, which is really dense foam for the transmitter where you hang your engines.
Yeah.
It's for an outboard or IO.
Okay.
And based on those materials, you can create the thickness that you want. Those materials are generally metric, just because they're coming from different location.
Yeah, that makes sense.
So you'll hear people say, "Oh, I need 2 mil piece there." That's a 2 millimeter piece of foam
Yeah.
or mat there to create thickness.
Okay, so if there's anyone listening to this podcast, structural engineering, but that's a mechanical engineer going into mechanical engineering, what would you say is like your top tips of like going into your first job? Like what should you be expecting?
Yeah.
What should you not worry about? What should you worry about? And kind of, I guess the big one is like we talked about how to pick your first job a little bit, and that it's really based off of like finding a good mentor and kind of finding a place that
Absolutely.
believes and like
Yeah.
educating you and like
Right.
and kind of helping you as a engineer. So what would you say for all that?
Yeah. So I think in terms of something to be concerned with is you shouldn't be. I mean, it's easier said than done, because you try to be prepared for it.
Yeah.
But something that someone told me a long time ago is, college is a platform for where you learn how to learn.
Yep.
Because you pick up different study techniques, you pick up things ways you can memorize things quicker. A lot of times you just really understand the concept at the end of it, and you're good, right?
Oh yeah.
But going to the industry in general, each company that I've been at so far, I'm learning something new, and it's literally starting almost from not always from scratch, but you're relearning the way the company runs, the culture of the company, how they do their calculations. A lot of times they have pre-templates made for you, so you're not really starting from scratch, but you're starting from somewhere that they've already defined.
Right.
And then based on the parameters, they'll have mentors that give you feedback. Something that, in terms of manager-wise, something to look for is a manager that isn't micromanaging. What I mean by that is someone who's not really checking on you every
Yeah.
single minute.
We'll just tell you cardboard.
Yeah, and
walk
it
Yeah.
and maybe
Cardboard walkway.
Yeah, exactly. And it's a good example there, right? Like if I have this new manager that I'm just starting to work the first day, and he's literally over my shoulder, just breathing. I'm like, no, you should cut this cardboard at this angle. It'd be really frustrating.
Yeah.
And so having that flexibility of just being creative on your own and being the engineer that you are, you should have the room to just trial and error, right?
And making
And
mistakes
make
and learning
mistakes,
from them.
exactly.
If you don't make mistakes, you can't learn from them.
It's okay to fail.
Yeah.
You make mistakes at job all the time.
Yeah.
I do too, and it's a matter of how you pick up when you do fail. Try not to make that mistake, second time.
And we're going life lessons
Yeah,
here.
man. So like it's the second mistake is usually your fault. This is a saying, but because usually you should learn from your first mistake, and if you make that same mistake multiple times, then maybe you're not fit for that.
Yeah, absolutely.
Yeah. So I mean, I'm sure from structural point, that's something that happens all the time too.
Yeah,
right?
we kind of hit that on the first podcast or something. Basically, that
Yeah, first week.
you're gonna mess up.
You're gonna mess up a
Just
lot.
once or twice.
Yeah.
Max and
In
I
the same
messed
way.
up. Oh,
A lot.
I'm
A lot
probably more
too.
than Max. I couldn't even design a beam my first week. It took me a day and a half. Now that's like a 30-second calculation.
Dude,
Like,
that's crazy, right?
I
That's all experience.
But like we were talking with our first experience is like I had the mentorship that didn't care about how long it took, didn't care
That's
if I knew how to do it or not, but it was just like you said, no, mess it up once, but you can do it again the second. You can do it the second time, right? You
Yeah.
learn from your mistakes,
Absolutely.
and you just keep learning. And that was like the big thing. Is like
Yeah.
we both learned so much.
Yeah, and it's okay to fail. It's completely okay to fail. I think
As long as it doesn't go out the door.
Yeah. As long as it doesn't cost the company, shut down.
Yeah.
Pretty good.
Yeah, absolutely.
Yeah, so that's one thing I definitely would, advise or just be concerned with. It's okay to fail. Admit to it. Be responsible for your actions. So that's something
Yeah.
that I think is also important in itself.
Yeah.
Your job.
Definitely.
Were there? It's kind of changing a little bit. But
Yeah.
I was thinking about structural engineers. Were there structural engineers at the company that were, or like they were saying that were helping with this form work? Like if someone is doing a structural path but doesn't want to do buildings, do you think there are a lot of positions in these type of companies for someone from that background? Like, do you think they would be willing to hire someone from a structural background
So Max-
to do what you were doing?
Yeah.
I'm
Max
looking
was-
around.
Max is looking at you.
No.
You want me to
I think
contact,
there's like, I'm liking these boats.
Yeah, no, they're absolutely awesome. Absolutely awesome. So yeah, in terms of that though, a lot of companies do like bringing engineers in with different perspectives.
Yeah.
So I went from the luxury boat world, which
Yeah,
is
boat yacht.
massive structures, right? Massive just engineering in itself. Now I'm in the medical, which is the opposite spectrum. It's tiny stuff.
Yeah.
So when I went for my current job in the medical world, they're asking what I did previously, and it's like, oh man, I don't fit this. That's another thing. It's like I already doubted myself, right? Which is something you shouldn't do.
Yeah.
I was like, man, I don't fit this. I definitely fit the job description, but in terms of what they were asking, like specifically what I was working on compared to what they
Like experience
currently
wise.
do, yeah, it's like nothing close. Like I was working on the floor, producing the wood on the production floor and getting dirty, and then in the medical world, it's extremely clean. Like I'm in nice clothes. When I go onto the production floor, it's you're suited up in clean rooms, and it's certified, and all this kind of regulation that's all in place, right? Which makes sense, right? Because these devices you're designing or helping produce is going to go into somebody.
Yeah.
And it requires so much documentations and making
So-
sure that it's within regulations. So
Within the structural
Yeah.
engineering world, everything we design is 90-ish% goes into production or goes and gets built, right?
Yeah.
The majority of the time, what we do gets built. And in a mechanical perspective, it sounds like a lot of things you did was more prototyping, and like your cardboard, you did over and over and over. For us, you can design a beam, right? It's just the beam. We're not going to design a beam a million times.
Right.
We try not to. Sometimes
sense.
architects push you to do that, but for for a mechanical perspective, do you see like with the medical job now, like a lot of your work actually goes into production, or is it like what's a good like ratio? Like a majority of the work Max and I do get built, like it just
automatically, yeah. So my company specifically is R&D.
Okay.
So we do a lot of research. So there's the specific R&D section. So they do a lot of research and development.
Yeah.
So I'm more of a manufacturing engineer. Is
Okay.
technically the title. So I do
like processes.
Yeah, I do process improvements. I do production support. So if there's issues on production floor, they bring it up to us and we figure out what's the issue and how to go about it in terms of solutions.
Okay.
But in terms of process improvements,
Yeah.
so there's a couple processes that I'm in the process of designing, and I have to prototype it, right, to make sure that it still fits.
Mm-hmm.
And something else that considers in the medical world is it biocompatible? Is it gonna cause any more issues with the process when you're trying to improve it? You don't want to add more issues, right?
Mm-hmm.
So I would do a prototype, get it quickly made, whether that's 3D printing or staying out of house to get it machined or machine it in house. Once we get that to production, we would have it do a test run.
Yeah.
So they would go through their normal process of using this new tool, but it's a controlled production set. So whatever's produced from that would be held into engineering storage, because
So
that's
now,
not validated
They
yet.
don't sell it at discount cost.
Exactly. You
For
don't.
this hard
exactly.
valve.
Exactly. Yeah. It's all very documented and tested. But prototyping it's really important because it really helps you find all the errors that you potentially would not find if you just send it straight into production.
Yeah.
Which I'm very curious in terms of your perspective too, because when you guys design, it's going straight into production.
Yeah,
You can't, I mean, it makes sense.
Yeah.
You can't build like a $20 million building to prototype it.
Right. No.
But
And
can you do miniaturized versions of that to prove a concept?
we've 3D printed some
3D
buildings.
printed, but it's not something that's done in the industry.
We didn't 3D print it more in a structural way, but more of just architectural overall,
Yes,
visual.
I see.
But we use preformed shapes 99% of the time.
Yeah.
And so there's less
Yeah.
prototyping needed. We know
Like
how
you more or
strong
less,
a
we just
14
look
by
at like
22 is.
sheer moment and go.
I see. Okay,
Yeah,
that
this
makes,
is the beam I need.
I see. That makes sense.
Okay, And
Yeah, so I guess that's a huge difference right there.
for us,
So-
it's more like we pick those shapes and pick all that, but then it's in the details.
Yeah.
Right? How does it all
Put
come together?
Oh,
How's it all put together? And then that's probably more, maybe towards more of a prototyping way. Like we don't test it really, but I mean, there's such standards in the industry
That
to
makes
do
sense.
that.
And you can really see the overall structure within the program too, right? So that
Yeah.
helps
Yeah, absolutely.
verify that. That makes sense.
Yeah. So,
so-
and then
I guess in terms of engineering or mechanical side is when you design something, there's tolerance stacking, which is something that I think a lot of engineers could improve on, including myself.
Mhm.
They're not very pushed on during school,
okay.
so they don't take into account for like let's say you have a hole, and this hole is a 2-inch hole, and you tell the machinist to make a 2-inch hole, so he's gonna make a 2-inch hole,
Yeah.
But it doesn't take into consideration of his tool size,
Mhm.
if it's exactly 2 inches, or is it plus or minus 2 thou, and then you don't give any specifications to that hole, and then that hole is meant for another bolt, and that bolt also has restrictions, right? So you
Oh,
got to
yeah.
really define all these numbers ahead, and the reason why it's stacking is because over time, if you go
These
down
build
kind
each
of these
other.
assemblies, it adds up,
Huh.
and the gap ends up being a lot bigger than you were anticipating, right?
Yeah.
So that's something that you can't necessarily. I guess you can account for it in SolidWorks or whatever CAD software you use, but visually you can't see that.
Mhm.
So
Yeah.
sometimes it takes physically prototyping it, building it, and then actually testing it on the floor to really capture these little details.
Oh yeah, I feel like that'd be something that's it's one thing to mention. You could say in school and you're like, oh yeah, that totally makes sense.
Right.
But not till you're like feeling your hand and feel that jiggle. You're like, man, where did that come from?
Yeah.
Like, how is it so loose?
Yeah, and like medical wise too, like on these CAD programs, you're zooming up to a pretty good size on your screen, so
Yeah.
you seem massive. Like I designed something with like a 3 thou wall, and
Jeez.
yeah, tiny, thin, right? I'm like, oh, that's not bad. But then when I zoom out, I'm like, because I had some machining experience prior to that, I'm like, just thin. I mean, but that's all a constraint have.
Yeah.
So I gotta make things around, move
So
it, and make it thicker.
Having that machining experience prior is
Absolutely.
really helping
Yeah.
this, what
Yeah.
you're doing now, and
Absolutely.
understanding, if that's possible and,
Yeah.
and what the machinist can do. And what,
Right.
you know,
Yeah, and
3
it's
thou
free.
seems pretty
It's
crazy
very thin.
for
right?
a wall, especially.
Yeah.
Super thin. Yeah. But yeah, wrapping this back to the your main question was in terms of preparation. I think experience is everything.
Yeah.
Degrees is important, but every day nowadays everyone has one.
Yeah.
So at least when I look for engineers in general, like that's something I look for, is experience. Like what internships did you have? And it doesn't have to be necessarily something that relates exactly to what you're currently doing, but if you have experience, like for example in a restaurant and you're a waiter, you can work under pressure, right, under stress.
Yep.
Dealing with customers, doing customer service. So you can really word it on your resume in a way where you could have a good starting position as an engineer, for example. Customer service, dealing with people, so you work well in a team environment. You can work under pressure. You're flexible
So-
in terms of learning. So
You said working with people.
yeah.
In school, did you think that was a trait that you really needed?
No, I mean
Because as engineers, you would like,
Yeah.
just sit behind a computer,
Right.
I never talk to anyone,
Yeah.
and interact with anyone.
Absolutely.
But like, I find like day to day, you're dealing with people that are
Yeah.
not
Yeah.
engineers,
If
and they
you
don't
can't
want to
communicate,
sit there and talk to
Yeah.
an engineer. They want to have a relationship. They want to have that conversation.
Yeah.
So
That brings up a really good point. I mean, as engineers in general, they're common, like, I guess
introverts,
very introverted
Yeah.
to themselves. Not
except these three right here.
we're a little different. We went to Wazoo, so go Cougs.
Go Cougs.
And
Took
so,
down the Buffs this weekend.
Oh, we destroyed them.
Yeah.
So that was
Good luck.
Yeah.
but it's going from that school, at least it allowed us to really be. You can't be introverted. Like it seems to be something that unless
You think there was a
really
culture
enjoy it.
at WSU?
What was it?
Or you think that was a culture at your school?
I think part of it
Oh, Washington
because
State, yeah.
there's obviously there's the Greek system, right, and it's a party school, but it's very well balanced in a sense of I knew a lot of engineers who were in the Greek system, and they're able to balance both.
Yeah.
And those engineers specifically were very sociable, like very talkative.
You have to be, yeah.
Could hold a conversation.
Yeah.
Nowadays, there's some engineers that can't, and that's a big thing. Like going through school, you have these teams that that the professors set up, right? You're working with
Oh, yeah.
group, so you have to work with them. Otherwise, I know multiple engineers, even now, like they'd rather do the whole thing themselves.
Yeah.
Yes.
Oh,
Have to do
absolutely.
anything. So I mean,
We know some of those.
Yeah, exactly. Yeah. But once you get into the real world, you got to really talk to multiple departments to get your job done.
Yeah.
At least from my perspective of mechanical, I have to talk to quality to make sure that I'm within the compliance, right? I have to work with design engineers to make sure that it's still within specifications, work with the machinists or suppliers to make sure that the parts that I'm asking them to make is within the specs or it makes sense. Right? And so it really helps when you're easy to get along with. Well, you're friendly, always say thank you. It's something that makes a
Yeah.
huge difference.
Yeah.
And be respectful to everybody, and it gets the job done a lot faster. But if you're dealing with somebody who is I guess, not sociable and they don't like talking to you, and when they do, it's very negative. It's a very tough environment to work to.
Yeah.
I think culture is a huge thing at work. You can get paid a
Massive.
decent amount, but if the culture is really good, you will be staying there forever. So it's something to definitely consider.
Yeah, yeah. Okay, I've been wanting to ask this question for a while.
Yeah.
So, then this is really trying to relate, our two different disciplines of engineering.
Yeah.
So Max and I, when we design a building, we work for an architect, and we get paid usually a set amount of money.
Right.
So per building, here's the fee. Boom. And it's up to us to figure out how to make the most money with that fee.
Okay, so you guys
Right.
get commission off those buildings?
What's that?
You guys get commission off those buildings?
Not as engineer. No.
Yeah.
Oh, I see.
No.
Okay.
So let's say a building costs $100,000, right? We need to design that building within $100,000. If we
I
go
see.
over, that's on us, right? Because we
Okay.
didn't get the right amount of money or fee or whatnot. So
Mhm.
and for that example, so every project is driven a lot of times with
Budget.
with the budget, right? I mean, everything in life's driven by budget, but. So we have per project a very strict budget that has no wiggle room, right? It's not like we can call corporate and be like, hey, we need another 100K, and they'll be like, okay, here's 100K, right?
Right.
And what I'm trying to get to is, it sounds like with R&D and what you're doing, there's probably budgets set, and that's what I kind of want to understand more of. Budget set for projects, but what is that wiggle room? Right? Maximum, we have no wiggle room.
Yeah, that makes sense.
If
You just start losing money once
you just start losing money, that's it.
Usually you guys have contracts too, right? Prior
yeah.
to building it, and
Yeah,
you're
there's all
setting
these
the
contracts set
figuring
up.
out the labor costs and all that stuff prior to that.
Yeah, and there's so many people that affect what our job, mostly mechanical engineers in different aspects of what you do affects our
These
job
are HVAC
massively.
mechanical engineers.
Yeah, so they,
Yeah.
they affect what we do all the time. I mean,
Yeah.
they want to punch holes in everything we do. And then they roll their eyes and we're like, you can't cut out 90% of our beam. And they were like, why not? It's just nothing against mechanical engineers. Obviously there's sometimes frustrations, but so we're tracking that, trying to stay on. But you want to do a good job no matter what. So
Right.
if we do go way over, we go way over. As long as we're doing a good job, that's key. That's number one. But for your role and what you do, how does budgets and stuff track? Without going, we don't have to go in crazy detail.
Yeah.
But very
I can-
broad. statement.
Very broad. So from the boat world, it was based on the market. So let's say they're trying to go build a 30-footer.
Yeah.
So they look at similar boat designs that are 30-footers and what they're going for.
Okay.
So then they'll have kind of a guesstimate of how much they could sell the boat for.
Mm-hmm.
So then that would kind of trickle down to how much labor should be, how much man hours should take to build it.
Bless you.
Yeah, bless you, sweetheart.
Oh wow. We're getting close.
Gotta throw that in there.
Yeah.
Makes it a little nice. So,
Yeah.
but in terms of R&D side of things,
Hold on, really quick on the boat.
yeah.
So let's go back to the example. $100,000 boat, let's
Yeah.
say, just like a $100,000
Okay.
building. And you said it trickles down. They'll throw in profit into that and trickles down. So for your first project, it sounds like with that table and cardboard, were you given, hey, this needs to take 3 days of work?
No.
Does this need,
Yeah,
or did
yeah.
they go design this table and just dropped it? They just gave you the time that you needed.
Yeah. So that's
How did they set expectations?
Yeah, so setting expectations is a big thing. So the way my manager went about it was, he was like, hey, you kind of have about a week. If you end up taking longer, that's fine. But
Okay.
if it does, you gotta have valid reasons why,
Mhm.
right? Like if you're just
Yeah.
messing around and not gonna get
Right,
jobs
it's just a
done, then
table.
obviously,
Yeah.
Just a table, very simple, yeah.
Yeah.
So
Okay.
he led me to it. So in terms of budgeting, that wasn't really accounted for.
Mhm.
So this is more still in the prototype phase.
Okay.
So prototype phase, you kind of have a general number of how much it will cost to do all these prototypes.
From past experience.
From past experience, right? So this is historical data.
Yeah.
Or it could be just a guess, right? Like engineers in general should be able to figure out this kind of problem in a week, for example.
Yeah.
And sometimes that's what they say, but in terms of budget, that's not something that is strictly followed, at least for the prototyping phase. At least from my experience.
Okay, so they're not like prototype this. You have 2 weeks. If you don't meet 2 weeks, you're fired.
Yeah, right.
That's not-
So
that's
there's a
not
lot of
a thing
flexibility
that-
from what I've experienced so far.
Okay.
I know maybe certain companies are maybe stricter.
Oh yeah.
Yeah.
Yeah, we're only coming off of your experience.
Yeah. So I'm just making sure the viewers are like, yeah, that's
Yeah.
not true.
That's not,
From my experience, it is.
From David's very
So
special.
it sometimes it.
I think you make all the viewers want to be a boat designer.
Yeah.
By the way.
It's not bad.
Yeah.
It's definitely fun.
Build giant
A lot
cardboard
of
boats.
cardboard.
Yeah.
There's pros and cons.
Yeah. So like
Yeah.
people have paper airplane competitions, you have like paper boats, and they're just all sank, and it's like a
Exactly.
joke and funny.
It'd be hilarious.
Okay.
Blow up.
Yeah.
Yeah.
Okay. Sorry.
So yeah, it definitely helps when they set the expectation, but a lot of times they don't, and you kind of just allow the freedom to do R&D. However, in the medical side, which I think maybe is similar to aerospace and other,
Yeah.
industry that's kind of related to that, is they do require you to record hours.
Mhm.
So that way they get a kind of general idea of how much you are spending on prototyping this, so they have an idea of how much to budget for the coming year, for example.
Yeah, I
So
think
give
that
them
makes a lot
a
of
generic
sense.
number, yeah. But I think overall, the higher end, top level executives, they do. I think they do have a general idea of like, prototyping this specific project, how much it would generally cost, and they would have fluff numbers in that to
Yeah.
help account for things that they don't see.
Mhm.
So I think they do have that high level number, but in terms of like breaking it down to like specific activities I do, where that table,
Yeah.
I don't think they.
Like design this bolt, you have 3.5 hours,
Right,
or
exactly.
we're blowing the whole
Yeah.
budget.
But in terms of production, though, that's another question. That's another
Yeah.
thing in itself. So, like, let's say, we just started the model. I mean, another thing to consider is in the boat world, they have seasons that make sure that to produce these boats within a time
That's
so
a
that
good
they can
point.
show it off.
Yeah.
So that's something I totally forgot about.
Does that constraint ever like bring pressure on you? It's
Oh,
like,
absolutely.
Oh, man, we gotta.
yeah. So they have
We gotta
something in Seattle that's it's kind of like the boat show in Seattle, right? Massive show.
Yeah.
So
Is it
that's
called
where-
a boat show?
It is called
That's
boat
so
show.
awesome.
So it's massive.
I hope an engineer named it.
Yeah, probably. It's simple. And so
I like it.
sometimes we have to hit these shows, so we want to have the prototype done.
Yeah.
And sometimes you realize that like a month in, and you're like, crap. So now you're working. So engineers in general, right? The majority of us are all on salary, so they're like, well, you're on salary, so you're gonna work, 8-hour weeks, whatever it takes,
Yeah.
weekends, whatever.
Yeah.
So you're working these rough hours to get this boat done. So then, there and then, it's definitely a deadline, but in terms of budget, not necessarily.
Okay.
It's essentially get the job done.
Mhm.
Yeah.
And that's what's nice also about engineers in general is, you guys can, jumping on this is, in terms of hours, it could be as flexible as you want, depending on your company.
Mm-hmm.
As long as you get your job done,
Yep.
and in a timely manner before the deadline. you're
And
all
you,
good.
for us, keep our clients happy.
Yeah, exactly.
Yeah.
So
You luckily are just working in house.
yeah,
We have to go talk
Well-
to a million people, and make them happy too.
you got to make the people inside happy too.
Yeah.
Right, like machinists. Like man, machinists is a big thing because if you design something, something that a lot of I guess engineers in general may not know is these internal pockets, for example, for CNC parts. They make it out of these CNC end mills, right, which is
Yep.
circular tool.
Mm-hmm.
And so these internal pockets, you can't have square corners.
Right. You
Right,
get
there's-
close though.
Yeah, unless you use
But
an EDM
very
or
rounded.
yeah,
Yeah.
very very close. But there's always gonna be a radius on there, right?
Yeah.
With these end mills, and sometimes engineers design it as square pocket for some reason, and
Yeah.
when they bring it to the machinist, they look at it. I'm like, are you an idiot? Or
Yeah. Have you ever done
these
this
process?
before?
Yeah, place, right? So making them happy helps because when you design something that's machinable and machine friendly in mind,
They're happy to do.
they're
the
happy and
project.
they'll take your project all day long.
Yeah.
Right? They're like, I don't want to take this other person. This is a crap design.
Yeah. So you kind of get a buddy.
Yeah,
Like,
so you build
kinda-
relationships.
Good
you know.
relationship with them.
Yeah, absolutely. You build a relationship with everybody that you work with, and it helps when certain projects come up because like, hey Zach, for example, you're
Yeah.
really good at specific designs, structural, beams or whatever.
Yeah.
So then I would go to him for questions, right?
Mhm.
So it helps when these type of individuals that are very good at certain things, and it
Oh,
really
yeah.
helps your project come together a lot, really quick.
Oh, I think finding like what everyone's good at in the company
Yeah.
or the firm is so key.
It is
Because you can just like, oh man, I need to design this. This
Yeah.
let's say this crazy lateral system or this tower, and there's one guy in the whole firm that has done it before, but no one else knows. So like,
Yeah,
it's just
see,
like
that's a good
you're
example.
coming to find these surprises of like, man, I really need to know this.
Yeah.
Like, and just knowing exactly who you can go to is
Yeah, and
It's
something
key.
to keep in mind too, like as engineers, a lot of engineers coming out of college is, oh man, this like let's say a wheel, you're starting designing from the scratch,
Yeah.
right? But you shouldn't because it's been around for so long. There is a
Oh,
template
yeah.
out there that you can
Mhm.
start with and then maybe modify it to what you like.
Yep.
So there's no reason to start from zero, and I think that takes a lot of ego, I guess.
Yeah,
You know, a lot of
100%.
that, and you know,
That's what you want to make the whole thing, right? It's
Right,
like,
yeah, you wanna
it's
start from
yours
scratch.
if you did the whole
Yeah,
thing.
but you're gonna have to. I mean, it took years to perfect, right?
Uh-huh.
That tower
Wow.
design, or example.
More than years to perfect
Yeah.
the wheel.
Yeah, easy. Yeah, though you got those small little holes here and there. Yeah, but no tower.
So you got holes in your boats, holes in your wheels.
S6. It's a good thinker. But yeah, no, the tower example you got, man, that's a good example because you obviously has some sort of basic outline that you can start with, right? And someone you can go to that's an expertise because they built a couple towers.
Yeah.
Right? So it doesn't make sense for you to try to start from scratch and
No.
it takes you
It's a
that much
waste of time.
longer.
Yeah.
It's inefficient. Yeah, exactly. So
It's a waste of budget, waste of time. You're spending.
Yeah.
I mean,
Why
so
start-
here's a great question.
Yeah.
Great question. So I would say, and Max, you tell me what you think to hear. On a day to day, I'd probably spend a little bit of it googling some answers. I
Oh,
go
yeah.
on Google
Oh my
and
God.
I'm like, how do I design this? What's the like? There's so many nuances and so many materials we have to design that you could spend all day just looking through books to find it. But Google is such an awesome.
man.
What's the
use.
forum we have? There's some like structural forum that
Yeah.
old guys will debate all day on there, and you can just go look
But you
in
go
on what
and
they're talking about.
they're all talking about like code sections, and so like you can go boom quick, and it is, you know, in school like you think you got to know everything. I'm gonna go to my job, I know everything. I can't use Google. Like in school, you know, sometimes you can't use calculators. You obviously
Yeah,
never can
it's
use
not-
Google on a
that's-
test, you know. And in the real world, it's so different. Now, I'm not saying that you should go to in colleges to be able to use Google and
Sure.
calculator, whatever is the rules. But because I think that really grows a certain area that is important. But on like your day to day, maybe stuff you're doing that is very, the stuff you guys are selling is very like classified, kind of secret, because you don't want other people to copy what you're doing. And so like with us, like it's not very secret what we're doing. Like
right?
Yeah,
makes
building,
sense.
making a building on steels, it's like it's very common. It's people know how to do it. So we can Google very specific questions, and it's not an issue. And I think if you ask a lot, most engineers, structural too, like they Google a lot.
Yeah. Oh yeah.
So like,
yeah.
but mostly you look for code references
Yeah.
to then go to the code.
That
But
makes sense.
For you, like, how does Google? And that's a very weird question, but how does like the internet and Google like affect your job? Like,
Yeah,
how much are
yeah.
you using it?
Not a lot. I say maybe 20% sometimes.
Okay.
And that only goes down to when I don't know how to go about maybe a calculation
Yeah.
or a quick equation that I don't remember the full formula.
Mhm.
Like recently, I've been doing a little bit of trying to implement an ISO standard in our company, and that standard I don't know fully well, so I had to Google a lot of rules in terms of compliance, what we need to do to be within compliance, and so that helped a lot. Then that also opened up resources to, like the city of Redmond, which is where it is, and the contacts I can talk to, and
Oh, yeah.
professionals. So Google in itself, it helps a lot with that.
Yeah, or just a search engine. I mean,
Yeah, search
Bing
engine,
sucks, but yeah.
Yeah, exactly. Anyways,
But yeah, do you
Yeah.
agree? Like,
Oh yeah.
yeah. It
I mean,
helps.
I wouldn't say my whole job's on Google, but
No, yeah.
I find a lot of things
Yes.
helpful, and like
Yeah, at least
sometimes,
once a day.
sometimes like a connection too. Yeah, at least
Yeah.
once a day. Like, man, I don't know how to detail this connection out, or like you're saying with this all goes back to the wheellight thing. Is like it's all been done before.
Yeah,
I mean,
exactly.
they're the massive firms that are coming up with new structural systems in general.
Yeah.
Like these massive
There's
systems
libraries
that
out
like
there.
no one's ever used before.
Absolutely.
Like they're doing stuff that you can't Google.
Yeah.
But
Us
for
peasants.
everyone else, like that's the top of the top. I mean, that's
Yeah.
less than the 1% that are doing stuff like that in engineering, in structural engineering at least. And so, I mean, for you guys, everything's like one off more or less.
It's-
Everything
yeah,
you're
it depends
prototyping
on
and coming
company,
up
yeah.
with. So,
And sometimes also is like Googling, software troubleshooting.
Yeah.
like, if I'm trying to design
That's
this
super-
part in a certain way and
yep, do that a lot.
try to make it so that's efficient, like how do
Yeah.
I go about it? Because I have an idea in my mind, but there's probably a more efficient way online.
Yeah, you're asking higher level questions, or but
Yeah.
try. You're not googling how do I do my job.
Yeah. So
Like, it's very-
exactly, like
yeah.
how do I design this constraint with whatever.
Yeah.
That does not exist out there.
Yeah.
Right? That's something that you gotta figure out, and that's another thing too is you gotta know the people who are good at certain things,
Mhm.
and this is where it helps you out. Like you set up meetings, and you bring up this I guess problem that you're running into, or dilemma that you're running into, and you present it to the group, and then they would, with their expertise and experience, they would
Mhm.
like, oh, you should think about this or consider this, whatever.
Oh, absolutely.
And that is what really helped the good well engineer in general, regardless of type of engineering.
So
Yeah.
it goes back to the ego thing.
Yeah, huge.
Ego shouldn't have a place.
Yeah, should not.
Yeah.
But that's you come out as an engineer, you're like, oh yeah, I'm an engineer, I can do everything. But
Right.
I know
Like,
some engineers only know how to use screwdrivers.
Yeah.
Like it's
but having humility in your job is really big, and
Yeah.
asking for help
Being
and
humble.
questions and
Yeah.
is huge in engineering. You'll get further
yeah, you will.
if you're not
Absolutely.
like, well, I'm going to design. I'm never asking anyone. I'll spend 2 weeks wasting time
Yeah.
rather than asking someone.
Sometimes you're in a meeting and everyone's trying to talk. You don't have to necessarily chime in.
Yeah.
Either sometimes you sit back and you listen and you
Oh,
kind of
yeah.
reflect on those questions. Really, you learn a lot more from that than if something trying to just chime in just to
Just to
Put
add
your 2
something,
cents.
just
Yeah.
to be heard.
right. And so it's something that I think everyone could work on. Just to listen, and it's huge. And I know this is kind of tangent too, but keeping design simple is much more difficult than anything. So that's why you don't want to start from scratch either, because you'll most likely design something that's extremely
Way too
complex.
complicated. Yeah.
And keeping it simple really helps with, simple. Like it's cheaper, it's probably lighter, it's just simple and less thing to worry about, less thing to fail.
Yeah, you came into it going, oh man, I got to design this crazy complex thing, and it really is
Right.
the simplest solution that works the best.
Yeah, exactly. And sometimes it's right in front of you.
All
you
the
don't think
time.
about it. Yeah.
Always. Yeah,
That's
you get down
always-
this rabbit hole. You're like, all right, this is what we have to do, and then someone else comes in and looks at it, and they're like, what the heck are you doing?
Yeah. It's like,
And if
How did you
you
get
sometimes you
here?
have to step back. I think that's
Yeah.
really important too. I
Yeah.
mean, you put a set of drawings together, and you kind of stand back, and you're like, is this the best system?
Yeah.
And even like, let's say for us, you're 80% through design, right? You step back, you're like, you look at a big global picture. Like, am I picking the right? Should this be a concrete building than a steel building? And like maybe you're at 80%, and you're like, holy crap! Like we're really far ahead, but like,
yeah.
kind of going back. That's a very rare. I mean, that doesn't happen very often. But,
Oh, that's
like
Yeah,
you
that
guys
would be-
design the
that's
whole
too
building,
far
but,
in.
like
over budget then.
yeah, like kind of going back and like we really looking the whole picture, not just that very narrow one little thing.
Yeah.
Is important, I think.
For sure. That's a huge thing. So
Yeah.
Is there any other questions?
I think
I think-
I don't know.
I think it's time
It's
you
good
ask
time.
us some questions.
Ask you guys
Yeah.
some questions.
Ask us some questions that you don't even know. Like ask us questions that you think are simple or complex about what we do, like misconceptions, things like that. Yeah, just a couple.
So I mean, from I guess it's a little biased, but from my perspective to trying to see what you guys do, you guys have it's almost like a library of all these beams, preset with lengths, condition, material type, and then you would take those, from the library and bring it into your building structure. So basically, you're
Basically.
just puzzling thing together.
There
and
aren't
you
that
should-
Like
many
when we're
variations.
modeling it.
Yeah. Is that something you do?
There's a very set. Or yeah, if you
Yeah.
want to take this one.
Well, it's just there's not too many types of materials. There's a lot of types of shapes. But
Okay.
yeah, when we're modeling something in a program like Revit, which is a BIM software,
Mhm.
we're bringing in a shape, and those properties and sizes are kind of in that in that software already. But yeah, as far as like what is the specific material, it's probably just going to be
Interesting.
grade 50 steel.
Yeah.
And then, but when you guys are actually building, how do you like? So something in the engineering,
this is
like
good.
so, tolerance is something that is huge, right? So like, let's say you have this beam that's in place.
Mhm.
How do you know it's gonna be built 100% to the drawing?
Yeah. So the
what happened if they're off by a couple degrees?
Yeah. So the governing body of more or less each material type, there's a code for each type of material we design,
Okay.
and they set the standards of tolerances, and so that's kind of built in with the safety factors. Let's say of our designs. So yeah, let's say our beam can have a 2-degree tilt.
Yeah.
Well, that's built into to our design. So if that beam has 2-degree tilt, they found that it's not going to fail the beam, right? So there has to be all these tolerances, and that goes for holes and kind of twists and curves and all that kind of stuff. There's all these tolerances built in that are to a safe limit. So that's like a manufacturing tolerance,
Yeah.
and some there's erection tolerances and all that kind of stuff.
Mhm.
And then in the field, they have to have inspections done to make sure that things are placed correctly and
Right.
We have a lot more
are
wiggle
lined
room
up
too.
as well.
Do you? Is
Oh,
that
yeah.
something that you guys do in the software as well to
No.
account
No,
for?
nope.
Like if it's too? Oh no.
Not at all.
I mean, the beam's going to be cut to the right length, plus or minus an eighth inch or a quarter inch or something, right?
Okay.
Like,
I would say a beam, couple inches, isn't going to change the.
Really?
Isn't going to fail.
Oh wow. Okay.
yeah, depending where it's placed. Yeah.
There's
You got
very
some-
specific
I mean,
scenarios,
our
yes,
bolt
but
holes are oversized. all of them,
Makes sense.
given some certain conditions. Sometimes they're not.
It's very broad in general statements, but
Yeah.
So like there is just some built-in movement until you crank things down.
and then like for like grade of steel, let's say for a steel building, like the grade of it will get the mill certificates
I see.
stating that they've been
Materials.
tested and they matched ASTM standards and all this stuff.
Yeah.
And so and a lot of that is controlled by the contractor because they don't want to build a building that is not safe, right?
Right.
So they keep track of a lot of that stuff, and they are typically the ones with the inspectors out there and tracking all that, provided by the owner and whatnot. But
Interesting.
so though all of those tolerances and like our materials have a minimum grade, but so they can be more. So most of our beams we design for 50 KSI. A lot of times they're way over 50 KSI. I mean they're not
Oh, sure.
100, but they're
Makes
over,
sense.
they're over
You
50
gotta be a
KSI.
safety factor, right?
Yeah, so we design for all these minimums, and then there's, just our loading is very conservative. You can argue a lot of that, but our loading's conservative. Our beam sizes, our grades of beams, etc., are conservative, and then we put safety factors on top of all that. So,
That makes sense.
yeah, I mean, I would say that's kind of how we track those tolerances.
Yeah, that's very interesting perspective.
But so like you're going back to your bolt hole,
Mhm.
you have a 2 mm bolt hole or whatever, and the bolt's 2 mm. Like everything we do is oversized, at least a 1/16 of an inch,
Just so that.
just for erection. Yeah.
Yeah.
And you start thinking about it, like a beam has to go in, and there's only a 1/16 of an inch. I mean, that's very tiny. So there's a lot of fit up room, and they're like pulling columns together to fit beams in there sometimes. Not a lot because you don't add in all this axial stress.
Has there
but-
been a time where they're building to the drawing, but they don't, in a way?
Like manufacturers mess up. Like
manufacturers mess up, and then so they end up getting a bunch of these shorter beams.
Oh,
So
yeah.
your overall
Oh,
building
yeah.
is
Oh,
a
yeah.
little smaller than you were anticipating.
Well, not quite like that. It would be
Oh,
like
no.
a beam shows up, it's supposed to be 20 feet, it's 10, and everyone shrugs, and
They
someone
order a new
yells,
one.
and they get a new one.
Or they'll call us and be like, "How do we make this 20 feet?" They're like, "You can't." They're like, "No, you tell us how to do it." You're like, "You can't."
Interesting.
We get a lot of those on us, I think.
I-
RFIs that are like, "Fix this." You're like, "You make a new beam," and they're like, "Well, what else can we do?" You make a new beam,
it's not
we
like-
have to have those conversations all the time. Not at that simple of a level,
Right,
just like a beam length, but things that are like, well,
Interesting.
you just have to redo it.
Do you guys also
Become a lot
develop
of
the
fixes,
bills
too.
of materials to them? Like how many beams you got purchased of this length?
Oh no.
Not really, no, not that.
Oh,
yeah.
interesting. So you just build the structure.
So our job is to produce a set of drawings.
Okay.
That is it. That is our
Oh, wow.
deliverables.
Oh.
Here's drawings, stamped and signed by a professional engineer in that state. That is, and
Interesting.
I mean, follows with calculations.
Yeah.
Like our deliverable is a set of drawings. Period.
And with the expectation of like coordination in the field. Like our job doesn't quite end there, but like that
No.
is definitely the deliverable.
Yeah. We help through construction, and there a lot of times in constructions, like you're saying, they mess things up, but we have to come up with a fix because the buildings. Let's say the building's almost done. Well, they forgot the anchor bolts. You can't take the whole building apart to put anchor bolts in.
Right.
So we come up with a lot of solutions to fix things like that. Anchor bolts is very common. Now that they forget,
Is
they
that-
misplace.
What is? I don't know what that is.
So like columns held in with anchor bolts, like
Okay.
threaded rod with
Oh,
nuts and
I
bolts
see,
and
I see,
stuff
I
in the
see.
concrete. A lot of times the guy putting in the concrete, he's the one that puts the bolts there. Well, sometimes he doesn't locate them right because once the concrete's poured, his job's done. So
Yeah,
he doesn't
right.
care necessarily how that lines up. So a lot of times they're not placed correctly, or they're crooked, or a piece of equipment. This happens all the time. Just drives right over the bolts. And now they're all
I'm sure
bent
that
and
happens.
crooked,
Yeah.
and they're like, so we cut them off and post install like epoxy set and new ones. Or
I see.
anyways, so yeah.
Cool.
Very interesting.
Well, I think that's
Yeah,
that's our podcast this week. So
Yeah.
Deal.
David, thanks for
Thanks
coming out
for
here.
joining us.
Absolutely.
joining
Thanks
us,
for inviting
so-
me. It's cool. Nerd
Yeah.
talk all day.
Yeah.
We're going forever. So
Well, we could go for. I think we'll have to have another podcast in the future.
absolutely.
Oh,
So
yeah.
then kind of go more in depth and.
Yeah.
If anyone has any questions for David or us, reach out to us on our we got
Instagram,
our email,
Facebook,
Instagram, Facebook
email.
listed
We
on
got
our
everything.
Yeah.
So-
YouTube, wherever this is
YouTube.
located.
yeah
On
Comments, comment
podcast
below.
podcast.
platforms. Anyways,
Yeah.
thank you guys for joining with us this week, and we'll.